Welcome to this tutorial on Measure-Command, a powerful Cmdlet in PowerShell for performance optimization. Measure-Command is an essential tool that helps you understand how long your scripts take to execute. Whether you're optimizing existing code or comparing different approaches, this Cmdlet gives you the precise timing data you need to make informed decisions about your PowerShell scripts. Measure-Command is a PowerShell Cmdlet that measures the time it takes to execute script blocks or commands. It returns precise execution time data, which is essential for performance analysis. This Cmdlet helps you identify bottlenecks in your code by showing exactly how long different operations take. When you're working on scripts that need to process large amounts of data or run frequently, knowing their execution time becomes crucial for optimization. The basic syntax of Measure-Command is straightforward. You use the Cmdlet name Measure-Command, followed by the expression parameter, and then place your code inside curly braces. The expression parameter accepts a script block, which is any valid PowerShell code you want to measure. This simple structure makes it easy to wrap any existing code and get timing measurements without making major changes to your scripts. Let's look at a simple example to understand how Measure-Command works. Here we're measuring a sleep command that pauses execution for 2 seconds. We use Measure-Command with a script block containing start sleep with the seconds parameter set to 2. When you run this, Measure-Command will execute the sleep command and return detailed timing information about how long it took. This basic example demonstrates the fundamental pattern you'll use for all measurements. When you run Measure-Command, it returns a time span object with several properties. The output shows days, hours, minutes, seconds, and milliseconds as separate values. However, the most useful properties are total milliseconds for precise measurements, total seconds for human-readable values, and ticks for the highest precision available. Total milliseconds is typically what you'll use most often because it provides a good balance between precision and readability for performance comparisons. Here's a more practical example that measures array processing. We store the result of Measure-Command in a variable called time. Inside the script block, we create an array with numbers from 1 to 10,000, then use for each object to multiply each number by 2. After the measurement completes, we use WriteHost to display the total milliseconds property. This shows how long the entire array processing operation took, which is valuable information when you're optimizing data processing scripts. One of the most powerful uses of Measure-Command is comparing different approaches to solve the same problem. In this example, we're comparing 2 methods of iterating through numbers. Method 1 uses a traditional for each loop to multiply numbers by 2. Method 2 uses the pipeline with for each object to perform the same operation. By storing each measurement in separate variables, you can compare which method performs better. This type of comparison helps you make data-driven decisions about which coding patterns to use. To get accurate and reliable measurements, follow these best practices. First, run your measurements multiple times and average the results for accuracy, because single measurements can be affected by temporary system conditions. Second, isolate the code you want to test by measuring specific sections independently rather than entire scripts. Third, minimize external factors by closing unnecessary processes and programs that might affect your measurements. Following these practices ensures your performance data is reliable and useful for making optimization decisions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.